26. So it says the average score for 100 teenage boys playing a certain computer game, it was 100,000 points per player. If the standard deviation of the population is 20,000 points, find the 95% confidence interval of the mean scores for all teenage boys. Alright, in Stats 250, we learned about two types of confidence intervals, using a Z critical value and a T critical value. A Z interval, T interval. To use the Z interval, we must know our population standard deviation. We use the T interval when we do not know our population standard deviation. In question number 26, we are given the population standard deviation if the standard deviation of the population. Therefore, this is going to be a Z interval. Therefore, I need a Z critical value. So, to find the confidence interval when it comes to a Z interval, and I'm going to write the formula in the condensed version. This is going to be the condensed formula. Our confidence interval is going to be our sample mean plus or minus our Z critical value times the standard error, which is going to be your population standard deviation divided by the square root of the sample size. Our sample mean in this case is going to be 100,000 points. Our population standard deviation is 20,000 points. The sample size is 100 teenage boys. And we need to find our Z critical value. We want 95% confidence, right? Therefore, our confidence level is 95%. To find that critical value, what we're going to do is we're going to go to your T distribution table. Because this is a Z interval, right? And we want 95% confidence. So you're going to go over to 95% confidence. You're going to go all the way down to the last row. And when you go all the way down to the last row, it gives you your Z critical value. In this case, the Z critical value for my 95% confidence interval is going to be 1.960, or just 1.96. Once again, if it's a Z interval, use the T distribution, go all the way down to the last row, and there is your critical value. So now let's compute our 95% confidence interval. That's going to be our sample mean of 100,000 points plus or minus my Z critical value of 1.96 times my population standard deviation of 20,000 points divided by the square root of my sample size, which is 100. We can do the inside. So 20,000, the square root of 100 is going to be 10. 1.96, bring down your 100,000, plus or minus. Well, in this case, 20,000 divided by 10 is 2,000. So 100,000 plus or minus 1.96 times 2,000. 1.96 times 2,000 is going to be 3,920. I should be using the calculator, but these numbers are pretty simple, at least for me. But yes, please do your calculations in a calculator. Once you get to this step, you're going to break that up into two parts. 100,000 minus 920, excuse me. You can put your mu in the middle. And then we have 100,000 plus 3,920. And this is where I'm going to use my calculator. Open that bad boy up. 100,000 minus 3,920. That's going to be 96,080. Mu. I'm going to change the sign in the middle. Plus 3,920 now. When I add that, that's going to be 103,920. So, based on my confidence interval, we are 95% confident that the true mean of teenage boys playing the video game, or the computer game in this case, is going to be between 96,080 points and 103,920 points. Alright guys, I hope number 26 made sense. Let's transition on to question number 27. Now, number 27 says, the average number of mosquitoes caught in 36 mosquito traps in a particular environment was 800 mosquitoes per trap. The standard deviation of mosquitoes caught in the entire population of traps is 100 mosquitoes. What is the 99% confidence interval for the true mean number of mosquitoes caught in all mosquito traps? Once again, when it comes to the confidence interval, we need to determine if we know our population standard deviation or not. In this case, the standard deviation of mosquitoes caught in the entire population means that we know our population standard deviation. And once again, that is going to be a Z interval. So this time, I'm going to give you the expanded formula. The one that you probably saw in the formula sheet. Such mu is between two values. Your sample mean minus your Z critical value times your standard error of your mean, which is going to be your population standard deviation, divided by the square root of the sample size. And you're going to do the same thing on the other side, except you're going to be adding your margin of error. Also, speaking of terms, just to remind you, we call this right here the margin of error. But let's not get into that. Just, reminding you guys what it's called. Our sample mean is going to be 800 mosquitoes per trap. Our sample size is 36 mosquito traps. The population standard deviation is 100. And now we need to find the Z critical value for 99%. So we can go back to the T distribution. Let's scroll to the top. We want 99% confidence. So that's going to be over here. Because it's a Z critical value, we're going to scroll all the way down to the last row. Highlight that last row. And here it says the critical value is 2.576. But there's a D right there. So we're going to go to our legend. And that D says that this value has been rounded to 2.58 in the textbook. So our critical value in this case is going to be 2.58. Let's compute our confidence interval. And it's really the same formula as I did in number 26. Once again, this is condensed. This is expanded. So we have 800 minus 2.58 times, that's going to be 100, divided by the square root of 36. And on the right side is 800 plus 2.58 times 100 divided by the square root of 36. In my calculator, I'm going to compute the margin of error. So that's 2.58 times, in parentheses, 100 divided by the square root of 36. And that's going to be 43. So we have 800 minus 43. 800 plus 43. When we compute, 800 minus 43 is 757. 800 plus 43 is 843. Alright guys, that is it to questions number 26 and 27. Hope that made sense. Hope you guys enjoyed my video. Hear me talking. I'm going to see you guys soon. Take care.